starting with the very basic. So the first kit which I have is the opposite kit. So we are using this kit basically for teaching integers, factors, multiples, and all sort of those things. So when we look at these, we have various coins and a board. So what we take is that we take the green side to be the positive integers and the white side to be the negative integers. So this is how we take it through. So just asking them if 2 minus 3, like we are adding two integers, I am taking two positive integers, and to it I have to add minus 3. So how will I do it? So I will be taking three white integers, three white coins. What does the two green represent? The two positive. And the white one represents the negative. So if I'm asking plus 2, so I will be placing two greens. And I'm asking minus 3, so I will be placing three whites. Now, how will I add them? The thing is that one green and one white will make up 0. Right? So when we see it over here, so one green, one white makes up 0. Other green, other white makes up 0. What are we left with? We are left with one white. So what does this represent?
-1.
-1. So this is how we introduce to them that 2 minus 3 will be -1.
Means we need to make a pair of one green and one white.
Yes, because one pair of green and white will be 0. White will be 0 because it is +1 and it is -1.
-1.
That makes up 0. So that is why they will nullify the effect of each other. Or till lakhs, if you can see it, these are the ones. Then we have the tens, hundreds, thousands, till lakhs. We have all the cards. So what we teach using this is, the main is that we have to match the edge. This edge, not this, but this edge we are matching. So if supposedly I have to make 99, so I am taking this 9 and I will be taking this 9. Because if I match it over here, it will make no sense, right? So these are the places, because this is the ones place which I have to hide. So we match it from here. So we even use it for asking them that, can you make various hundreds, the next 100 places? The skip counting, we can say. We can also teach them skip counting through it. If like they are small grades children, so we can take up to 3 digits, right? Suppose I have taken 899. So can you tell me what will be the next 100 value to it? So what does that mean? I will have to change this value. I will make it 9 now, right?
Yes.
So this is how we make them understand two place value cards. We have these place value cards till lakhs. And all of them are from 1 to 9. We can make all the numbers using them. So we can teach them skip counting through it, the place value system, the ones, tens, hundred, thousands, and formation of the 5-digit number, 4-digit number. How do we form those numbers? So we can use the place value kit for all of these things. So now it becomes 20.501. And we can also teach them the place values through this, that why is every 9th coin and the 10th coin goes in here. So this shows that 10 of this will make 1 this. So each value as we are moving from left to the right is 10 times of the previous one. As we are moving from left to right, this is 10 times of this. So this is all we can use it through. So the base 10 blocks are something like these. So we have different blocks over here. So these are these ones. Now, this represents the one complete whole. These are representing the 1/10. These are representing the 100. And these are representing the 1000. Right? So also, because we can, if we want larger number of whole numbers, so we can take it to be the complete whole numbers. Then this will represent the 1/10 and this will represent the 100. We can even make it like that.
Actually, I'm confused over here. 100, like the 1000 and 100.
No, actually, like suppose we are asking them 2.1 plus 3.2. So for that, we need, because we are taking this as a whole, so we might require 5 these. But that will be too cumbersome to represent. So instead of taking this as a whole, we are ignoring it and we are taking this as a whole. So if I want to represent 2, I will take 2 of these like this. I've taken 2 of these. So if I'm taking these as wholes, so these will be 1/10. Why? Because if I join 10 these, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Second. Yeah. So I have taken 10 of these. These is making one complete this. Right? So if I am taking this to be one complete whole, I will have to take these to be 1/10. And if these are 1/10, then these will be 100, because if I take 10 such small cubes, they will give me one this rod. Right? So for easier, what we do is we take these to be the whole numbers. We take the rods to be the 1/10 and we take these small cubes to be the 100. Right? Now, if supposedly I am introducing then subtraction and I say 1.24. So I've taken 1.2 and I have taken 4 of these. 1.24. Now from this, supposedly I need to subtract 0.06. So I'm taking 6 of these. 1, 2, 3, 4, 5, 6. From 1.24, I need to subtract 0.06. These represents 0.06. Now, how can we subtract it? We have only 4 small cubes over here. But as we said that this can be replaced with 10 such small, right? So we replace this and put 10 more small cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we have so many of small cubes. Can we remove 6 from them? 1, 2, 3, 4, 5, 6. So what are we left with? 1.1 and 1, 2, 3, 4, 5, 6, 7, 8. 1.18. Equations. For example, I have an equation as to x plus 2 equals to 9. So what is the number I have? I have 9. So I take a 9 strip. And on the other side, I had x plus 2. So I put the 2. Now, what should be this gap over here? What should be the number that comes over here? So that this gaps get filled. So from the strips, we get that this gap gets filled with the number 7. So that means that the value of x is 7. So we use it to teach the equations. Also the fraction.
To represent a negative variable.
Yes, to represent a negative and a positive. So this is positive x square, negative x square. We can take in positive y square, negative y square, whatever is the equation about. Similarly, this is a positive x. Sorry, this is a positive x and this is a negative x. And similarly here, the positive and the negative number. So if we have a certain equation, we have to subtract two equations. We have to add two equations. Supposedly, I have one equation as x plus 1, two expressions as 2x plus 5 and x plus 1. Now, how I am required to add these two expressions? So, I will be taking two of these. These represents 2x. Let me take the red ones right now because I have a blue table beneath me. So, I'm taking the red one so that it is clear to you. So, these represent 2x. And plus 5, so I will be taking these 5 small one because these represent the constants. So 1, 2, 3, 4 and 5. To this, I have to add x plus 1. So which means x and plus 1. Now I can just combine, which gives me 3 rectangles and 6 squares. So on adding both the equations, what I get is 3x plus 6. Two into 4 plus 3. Now, if I have to use the distributive property, so this becomes 2 into 4 plus 2 into 3. Now, how to teach this, that why is this becoming this or why is this becoming the opposite? So what we take is, we are taking 4 plus 3. What is 4 plus 3? 7. So I am connecting 7 cubes. 1, 2, 3, 4, 5, 6, and 7. I have connected 7 cubes. Now I have to take it 2 times. So I will be taking another one. So I have it made. Right? So these are the 2 7 cube rods I have. So this forms up my left hand side. Now how does this right hand side come in place? If I break these into 4 and 3. 4 and 3. And again I break it into 4 and 3. I have taken 4 2 times. I have taken 3 also 2 times. Now can you count the total number of cubes? It remains the same as it was previously when I was taking 7 2 times. So this is how we distribute and teach them the distributive property. So these are the angle formation kit. These kits come up with some rulers. We have the complete 360-degree protractors. I am sure you must have used the 180-degree protractors. So these are the complete 360-degree protractors. And we come up with various screws as well. So what are the purpose of the screws is, we make different shapes using these rulers. Now, what do I mean by shape? Like when we are making them learn the parallel lines, the intersecting lines. So we just take up the screws and the connectors. Now, suppose I am making them teach the intersecting lines. So if you see the ruler, there are various holes in between. So for intersecting lines, I am connecting two and joining. And for easier, I am just joining it with the screw. I attach the screw up. And I just make it like this. So we can teach them the point where we have screwed them up. It is the point of intersection for the intersecting lines. The point where we have screwed them up, because we will be screwing two intersecting lines at one point. So this is the point of intersection. Now, along with these rulers, we can screw up the protractor. Now, what is the need of screwing up the protractor? With this, we can tell them that the vertically opposite angles are equal, because there are degrees mentioned on the protractors. So the degree over here is the same as the degree here. And these are opposite to each other. So while teaching the properties for perpendicular lines, intersecting lines, parallel lines, we make various shapes using them. Like while teaching the parallel lines, we need two parallel lines and a transversal. So again, making up the same shape, I have taken two parallel lines. Just clear it up. Yes. So I have taken the two parallel lines and this is my transversal. This way we can tell that why are these lines parallel? Can they ever meet with each other? They will not. They are going endlessly. Now with the transversal, again, we can use the protractor, attach it and tell them why are the corresponding angles equal? How are they coming out to be equal? And connecting with the screws and connectors and all the protractors again. Like I've connected one, I've connected second. So this way I have made it. Now again, I can tell them the angle sum property for the quadrilateral. Add up all the angles. They make up 360 degrees. Right? And in case, like, also the properties of various quadrilateral. I have a square. You can see that all of them have 90 degrees. All the lengths are the same. So instead of randomly telling them that these are the properties, they have a figure in front of them with rulers and protractors. They can easily observe it. That yes, we have constructed all the sides are same and all the angles are also 90 degrees. So such a shape is known as a square. Now I'm just removing it and I'm making it little big. I've just extended one side. Now this is no longer a square. Now this becomes a rectangle. I must say this is a very, very useful and a very interesting kit to use it, the angle formation kit, because there are a lot of things which we can teach using this kit. Like all the geometry concepts, basically, I would say we can teach them through this kit. The triangles, the quadrilaterals, we can construct the parallelograms and teach the properties for parallelograms. We can even make a hexagon, a pentagon to show them that they have 5 sides and this is what it looks like. So this is a very, very interesting and a useful kit and very easy to understand for students by seeing it. So they easily grab it and they are not cramming it any further.